Good morning, ladies and gentlemen. Welcome to the live stream at Volta-X in Stuttgart. Today, the title of this next half an hour will be Long Duration, Secure, Sustainable Energy Storage Solutions for 24/7 Renewable Energy, based on vanadium redox flow technology. CellCube is a global leader in vanadium redox flow batteries, which are used for long-duration energy storage applications. CellCube is a scale-up company with fast-growing into double-digit millions revenues. It's the product brand of the company Enerox, which is a limited company headquartered in Austria with an own production capacities and competence center for sales and services. Because of the high development engineering and the track record of the projects over the 20 years, the company has a very good setup into the energy storage market with 140 projects, 40 mega and 75.3 megawatts already installed and contracted. CellCube held also higher standards of 10 patents and also technology readiness level of 9 for industrial grade megawatt. The reference of CellCube are multiple and are proven in the field. Between the climate zones in the world, 30 degrees to 50 degrees, in more than 20 countries, without interruption of 6 million of operating hours, starting with a small size up to larger scale sites of minimum 200 kV. The reference provides in milliseconds and seconds and minutes frequency regulation, or for long duration energy storage applications, shifting renewable energy from 4 to 8 to 12 hours, and also provide resiliency where there is no grid or the grid is weak, giving as a green backup power.
So, and as JC talked now about some applications about the vanadium redox flow battery, I would like to show you what is the technology of the vanadium redox flow battery. So, if you want to build a vanadium redox flow battery, first of all, you need 2 tanks. In the tanks, the liquid electrolyte is stored. The more electrolyte you have, the more energy capacity you have. As second, you need an electrochemical cell. This cell, you can put more of those cells you can put together like a sandwich to a so-called stack. The more stacks you have, the more power you will get. So we see in the vanadium redox flow battery, the energy capacity and the power are independently scalable from each other. As a next thing, we need some pumps to pump the electrolyte liquid from the tanks to the cell and back. As every battery, also the vanadium redox flow battery has a plus pole and a minus pole. So if you want to connect it to the public grid, you need a DC to AC converter. So with this DC to AC converter, you can connect either to a microgrid, an island grid, or to the public grid and supply your customers. So now we can start to pump the positive and negative charged liquid electrolyte solution from the tanks through the cells and back. In the middle of a cell, there is a thin membrane. This membrane separates the positive and the negative charged electrolyte from each other, and it enables ions to pass through. So with these ions going through it, you get your voltage and can create your electrical circuit. As the last point now, the positive and the negative pole of the stack are connected via current collectors to the electric cables. And with your plus and minus electric cable, the electrical circuit of the flow battery is established. And here on the bottom, you see a small picture of a stack where you see that, like a sandwich, the single membranes, bipolar plates, felts are put next to each other, and they form a stack. Now, this was the technology. Now I would like to go on to our products that we as CellCube can offer to our customers. So the product name is CellCube, and the first two letters are FB for flow battery. The first number shows you the rated power in kilowatt. The second number, the usable AC capacity in kilowatt hours. Here on this side, you see that a CellCube has containers on the top. These are the power units with the stack. They define the power. And in the bottom, you have the energy containers with the tanks, which are filled with the electrolyte liquid. They form the capacity. With these modules, we can combine different models of our flow battery. For example, if you have one top container, it's the FB250. It has a nominal power of 250 kilowatt. And every CellCube can have 200% of maximum power, so it would be 500 kilowatt. With the amount of bottom containers, you can form now your usable AC capacity. And so you can have 1,000 kilowatt hours for a 4-hour discharge battery, 1,500 for a 6 hours discharge battery, 2,000 for 8 hours, and 2,500 for 10 hours. This would be our standard products. And if you put 2 power units on the top of the container, you get an FB500, which then, of course, has a max power up to 1 megawatt, and in this case, the 4-hour system. The standard ambient temperature range of the CellCube is -15 to +45 degrees Celsius. But here, not the peak point during the day is important, but the average 24-hour temperature. And as in most of the regions in the world, the day temperature and the night temperature are quite different. The standard configuration is good enough for most sites on this planet. If you want to go to, let's say, Alaska or very cold regions, or in the desert, we can optional offer you other climate options. And on the left side, you see now examples of our systems. So the first 4-hour system, the FB250,000, has 1 top, 2 bottom containers. Here is the example of the 8-hour systems with 3 bottom and 1 top container. Or if you put on the same system a second top container, you get double the power, FB500, and 2,000 kilowatt hours. Now let's have a look inside a CellCube. Here at the example from an FB250-1000. As we said, in the top container, there are mainly the power stacks. They define the power. But also the switch cabinets. It's a DC and AC switch cabinet. DC for the connection to the battery, AC for the connection from auxiliary power to our pumps and the battery management system, etc. As I said, there is the battery management system. This controls the DC part of the battery, the pumps, the sensors, the temperature management system, and some safety equipment. We have pumps, as we said, to pump electrolyte through the system, through the stacks, and some sensors like leakage sensors, pressure sensors, temperature sensors. And on the bottom containers, there are mainly just the electrolyte tanks. They are big plastic tanks. Every single tank sits in a second containment. So this means if one tank would be untied and electrolyte could leak, then it would be caught in the second containment, and in there is a leakage sensor so that we get a warning if something is untied. Our complete safety system is also double-checked by the TÜV Süd product service. Now, if we want to go into bigger energy storage plants, we would use, for example, an FB500-2000 as basic system. And now it's really, you put one of them next to the other, and you got 1 megawatt, for example. You double it again, you got 2 megawatt, 8 megawatt hours. Here on the bright box, you see an example for an inverter. And this you can go up to 5 megawatt or even 50 megawatt if you want to. It's all plug and play. The containers are transported by ship or then by truck on land. On site, they are lifted down with a crane. One is put next to each other. They are connected and the system is ready. These big power plants are, of course, also available for 6, 8, 10, 12-hour applications. Now I would like to sum up again the key information about our cell cube. As JC said before, we have more than 140 projects installed all over the planet. The system is easy to scale, as well as power to energy ratio, as well as putting one next to each other and making big energy parks. It is a high-performance system for industrial-grade, heavy use, so really 2 or more cycles per day are fine if it fits to the application. The system has a lifetime of 25 years plus. We can use 100% of depth of discharge. I mentioned overrating already. It has no negative effects on cycles or lifetime. The chemistry itself has a sub-second response time, so the response time is really defined by the control loop and the inverter used. And we can have discharge times up to 24 hours. It's a reliable system. We have a system for more than 12 years running in continuous operation at an independent customer. As I said, you can connect it to island grids or grid connected. We can offer an insurance by Munich Re, so it's a bankable solution. And the electrolyte itself is safe, it's non-flammable, non-explosive, and the whole concept is approved by TÜV Süd Product Service. And about the topic sustainability and reusability, I give on to my colleague Magdalena. Thank you.
Yeah, how to quantify sustainability of a product. We did this with a life cycle assessment, an LCA in short. With the LCA method, resource consumption and the product's impact on the environment can be investigated. LCA studies are ideal to identify hotspots from products on the environmental side and also to compare it to other products. In an LCA, all materials and resources which are needed for a product, from the extraction of the raw material from metals, for example, all this is accounted and then it is converted into CO2 equivalents. So there is also, you can see on the slide, methane in it or carbon dioxide. As the basis for our LCA, we used the FB 500-2000. You heard it from Michael before. So this one with the 2 containers on the top and 3 on the bottom. A cradle-to-gate approach was chosen for the impact assessment, including the extraction of raw material, the manufacturing of the battery, the distribution to the customer, and also the energy consumption for 20 years. So what did the assessment show us? The manufacturing of one cell cube has an impact of 32.6 kilograms CO2 per megawatt hour. Is this much? Is this less? We don't know. So what did we do? We compared it with an LCA assessment from a university. It's really a proven one. Weber et al. Made it. And what we can see on the slide on the left, the Weber et al. Counted the lithium battery for 58 kilogram, so kilogram CO2, and ours was less. But what is the most important thing here? So this is all used with primary material, new materials are used, but this changed massive. When we use reused material and we can use recycled electrolyte, we can use recycled or reuse electrolyte, we can use containers again, we can use the shelves again, and so on. It's a massive drop in the emissions. So it drops to 11 kilogram for our battery. This makes a change of 73%. It's the difference between lithium and our product. But why is that? How can this be? The main reason for this huge difference are the values in the reusability of the product itself. The electrolyte is responsible for 70% of the whole battery weight and also for the largest amount of emissions. Why? Because of the vanadium, the sourcing of vanadium. If we would conduct an LCA with different sources from vanadium, like from steel industry or from flying ashes, we would get a completely different value in a positive way. But this is in work, so stay tuned for that. This leads me to the point of circular economy. So our battery, as said, is 25 years minimum lifetime. There's no degradation, nothing. So you can use it as long as you want. And after the end of life, if it comes to an end of life, 85% of the whole system are reusable. The rest is nearly to fully recyclable. Other benefits of VRFBs are, you can see on the left, we don't use any rare earths like lithium does, and also it is, they are safe for the environment, that Michael said before. Here on this slide, I want to show you only in short the comparison between other technologies here with lithium. So the differences are massive in some points. The electrolyte has no degradation for the vanadium, and there are no aging effects, for example. The depth of discharge, the DOD, at VRFBs we use the full range of the charge. VRFBs also offer unlimited cycles. The cost difference, and this is a massive point we see now currently because some lithium batteries are coming to end of life, they are huge because the recycling costs are exploding, and for our battery, for example, or for VRFBs in general, you really have to, you can reuse 85%, so the costs are completely different. And the most important thing, it's not flammable, nor explosive, and safe. But let's talk about solutions. JC?
Thank you very much. And down we got to the offerings that we like to give to you. We are working in 4 different market segments. We call it sectors. These are the energy sector, the industrial sector, the commercial sector, and the green infrastructure sector, in the critical infrastructure. We are focusing on the industry and creating also microgrids. Our offerings for these sectors are based on one AC solution, which combines a DC flow battery together with a DC-AC converter and transformers and switchboards, and also adding control devices. CellCube can be integrated in one microgrid for behind-the-meter applications, or can be integrated in one standalone battery system or in hybrid plant for in front-of-the-meter application. What we see here is a classical microgrid, industrial microgrid, grid-connected. And what is to do there is to manage the fluctuating generation profiles. The distributed renewable energy on one side is fluctuating, managing the shortage of the grid capacities, and also to cope with high peaks of the consumers. Why we are doing this? It's because we see there's a lot of challenges and energy risk that our customers are facing, and we would like to bring there a solution for that. In an economical sense, a commercial solution. We would like to turn these challenges into commercial benefits. And what are these commercial benefits? Reduction of grid cost, reduction of charges, high integration and self-consumption of renewables, which generates at 0 cost, reduction of peak loads demands, not having load shedding for their production facilities, and also savings in energy purchasing and energy bills. And why and how we do it? We are creating different use cases and applications. And in this slide, exactly from the left to the right, is going to diversify these applications in terms of duration of discharge. We see on the left side, very short term or very ultra-short-term applications, as example, frequency regulation, voltage regulation. And in the middle side, we see classical peak shavings. We can take more even than 1 hour. And on the right side, we see a classical renewable time shifting, which actually is the niche of the application for the vanadium redox flow battery. And I would like to say something about it, that the renewables time shifting is the only way to decarbonize, and we are seeing that more renewables can be integrated into energy systems of the customers. How does it work in reality? Here we can see one explanation of the low profile of one industry zone with a 70 megawatt demand peak, with a portion of grid connection at 10 megawatt, a portion of renewables, wind 5 megawatt, 10 megawatt PV, and the battery of cell cube. So every mix of possible sources, including the grid, serving the load. However, not everything is good economical there, so we need to optimize. We optimize by using the battery, and how we do it? We need to charge and discharge from time to time from the cheapest possibility, and that is the wind. When the wind in the early morning is blowing, we charge the wind. And at the same time, looking for the solar energy during the day that can be also help us to charge in case of there is surplus. In case of not, we are charged by the wind and discharging during the day. Why? Just to help to eliminate the peak or the peak power demand for longer periods. As example, we eliminate from 70 mega up to 10 mega, 7 mega during 11 hours between 6 o'clock and 5 o'clock in the afternoon, when the production of the industries in this zone is running, activated. Another case is showing when you have a grid restriction of 500. That means you cannot take everything from the grid, even the grid is cheap, because you don't have enough connection lines there. Therefore, but you will have a good portion of PV installed, and the surplus of the PV will charge our battery in such a way that we make finally kilowatt hour during the times when the solar is not producing. We discharge, so firming the solar energy, time shifting the solar energy as a fully. To finalize our offerings, we have a very wide range of offerings, starting from the simple turnkey solutions and systems, where there's actually the product, the DC product and the AC product, up to professional service solution design, which is actually combining different use cases, customizing the products, bringing solutions out of these products to the customers, and over this to the OEM service. The OEM service is up to 30 years even, to create a sense that the lifetime of the project can be, together with the vanadium redox battery, be so long for creating good economies of scales. These services are in different scales. We have levels of services, scale 1, 2, 3, and also we can allow to get performance guarantees over the 30 years. Financial possibilities to help to decrease the capex are also there, offered by us, and there's one of these is the electrolyte. The electrolyte can be offered as a leasing, or even to be repurchased by us at the end of the lifetime of the project. I thank you very much. In case you have questions or you have a request for a project, please don't hesitate to contact us anytime. We will be here also in the booth number, in the hall C9 and booth C3, 14. Thank you very much, and thank you also my colleagues. Bye-bye.